Okay, so now we're going to be going on to type 2 projectiles. And before we begin, we actually have to know something about launching angles and component velocities. It's kind of like the reverse of the type 1s when we came in at an angle, like the impact angle is different. All right, so the objectives, I can solve for component velocities using a given launch angle. So you have to be given a velocity and a launch angle. And we're going to break it into x and y's. So blah, blah, blah. Answer the following questions by writing to the tenths. Use Pythagorean trigonometry identities to solve these equations. So here we are. We're going to have this cannonball. It's not perfectly aligned up, but I did the best I could by drawing these arrows into Google. I have this cannonball. It's launched at 40 meters per second. But in order to really understand what's going down here and break it down into simple components, you have to identify the velocity of this cannonball that makes it go horizontally and the velocity of this cannonball that makes it go up. So we need to break it into components first. I kind of wrote that out for you, but let's just kind of relook at Sakator or whatever you guys learned. So if you have a right angle triangle, you have these identities where this is your hypotenuse. Yeah, however you spell it. This is called the opposite. And this is called the adjacent. That's if we're looking at an angle like right there, theta. And this is adjacent. Oh gosh. Adjacent. Yeah, however you spell that word. Blah. Adjacent. Okay. So however you learned it, I learned this really silly combination. This relates angles to the lengths of the triangle. So we can use this information that you learned either in geometry, I learned it in trig, that this is the sine, this is the cosine, or the tangent. That's what you kind of see on your calculator. So if you've never had that class before, you kind of turn your calculator on. Ta-da. Clear it. You have these ones, cosine, tan, and cosine, sine, cosine, tangent. What are these? When I was a kid, I had to look these numbers up on tables. They're really kind of annoying. That if you knew this length, you could find that angle. If you knew this length and that length, you could find that angle. If you knew that length and this length, you could find that angle. So that's what this is going on, trying to do. So I'm going to let's try to find out what this velocity initial in the x component is. So we have this like cannonball, green, and it has this initial velocity of 40 meters per second. But I'm only interested in the part that makes it go this way for now. So that is going to be the adjacent side over the hypotenuse. So I look here, and that means I could use the adjacent side, that's the A, over the hypotenuse. So all right, let's figure this out. That I'm trying to find. All right. Cosine of that, I probably should put thetas here just to be a little bit clearer. Cosine of that angle will give the adjacent length, A, over the hypotenuse. All right, let's plug in what we know and what we don't know. Well, we were told that this angle was, according to the sheet, 30 degrees. So I can plug that in. Cosine 30 degrees. Now I have the adjacent, and I don't know what that is, but it is going to be the component of that. So I'm going to put velocity initial x. Velocity initial x. That's just like the x component of it. And what was the hypotenuse? That was the full velocity that cannonball shot off at an angle. So that's the full velocity. And I'm going to put 40 meters per second. Make that kind of small. Now, how do I solve for v initial x? Well, I have to do my little fancy algebra stuff. That would be nice, I guess. You multiply what This, I'm trying to get this by itself, trying to solve for that, solve. And the 40 meters per second is dividing by that number. So what I do is I multiply 40 meters per second to both sides. And then those cancel out. And then I'm left with 40 meters per second times cosine 30 equals V initial X. And then, I like to write it all neat. I'm going to get rid of the units and put them at the end, I guess. 40 cosine 30. Now, if you look at your physics reference table, it's kind of sort of given, but it's hidden. It's right here. It's the next two equations. It says this A component of any vector is equal to A sine theta. But we were looking for the X component, so we're going to look for A component of some vector is cosine angle. Is that what we actually got? Yeah. So this is, instead of writing A, they write Vx. It's the initials, that's why I'm writing a little I there too, okay? And then it uses the full velocity, or, the full vector angle. So that's where you get the 40. And then you're going to take cosine, or whatever the angle is in it. Cosine 30. Now, how do you plug this into your calculator? Last step. I hate all these glary things. So it should be like an anti-glare lens. Probably cost me a pretty penny for that. Who knows? I don't know. Gotta win the lottery one day so I can buy all these fun tools that I know are out there. A light that doesn't cause glare. All right, so I put 40. Now I can put cosine. So I hit cosine. Now I'm not using that inverse cosine. I'm actually using cosine. Cosine, so I just hit it straight. Notice no -1 there. That's like the reverse of the angles. And then I put my angle 30 in there. You can close a parentheses, but it's just a waste of time for me. All right, now I had to make sure, if you didn't get that number, if your calculator is in radians, this is going to be really weird. But we're going to use always degrees for physics. So just make sure your calculator's in degrees. All right, and that's, let's round. Let's just call that 35 degrees. That's what we're going to do. Oh, not degrees. Oh my goodness. Velocity. And maybe we better be a little bit more precise. I'm gonna round to the tenths then. 5 or more up the score, 4 or less, drop that mess. Here's the 4, I'm gonna drop it. So the initial velocity in the X component is not gonna be the full 40, but it's gonna be 34.6 meters per second. That's the velocity that makes the cannonball go horizontally. So that little green line right here is 34.6 meters per second, and that is the initial velocity in the x-axis. So it has to be less than 40. Now, don't be tempted to say, oh, I just subtract that and get to the opposite. No. It's going to have another number. Now we're looking for the component that makes it go up. Looking for this spot. So here's your 40. I'm looking for this. So now I'm looking for, let me put this in. This is going to be the initial in the y component. What's that? I don't know. So now I gotta do my fancy footwork again. I don't have to keep rewriting it. I'm gonna start over here. So I gotta look for the angle, the information that has the opposite stuff. So here's your full hypotenuse. That's a 40. So now I'm gonna put sine, because that has the O for opposite. That's an O. Make a little curly Q. So sine theta equals the opposite length. In our case, it's going to be velocity. Make a little curly, so it doesn't look like a 0. And then the hypotenuse. Now plug in what I know. Still going to have angle 30. So I'm going to write sine 30 equals, and now I'm going to, instead of putting opposite, I'm going to put what the value really is. It's V initial and the y component of that velocity, divided by hypotenuse. 40, and I can put a little meters per second, just, almost 4 degrees there, oopsie daisy. So now I got to solve for v initial y. The 40 is dividing, so I got to multiply that by both sides. I multiply 40 meters per second both sides, because what you do to one side, you got to do to the other side. 40s cancel out. Then I'm left with v initial y equals 40 sine 30. I rewrite it the other direction. V initial y equals the full component of 40, the full component of that velocity going partial. Well, how much partial? Sine 30 partial of it. And what do I get? Put that in the calculator. Clear thing. Make sure you're in degrees. The little symbol degrees. I put 40. Then I put sine. 40 sine. And then I need the number 30. That's the angle. What do I get? 20. And what's the unit? Well, the unit over here is really, meters per second. Meters per second. You can ignore that if it makes it difficult for you. Meters per second. So V initial component in the Y is 20 meters per second. See how it's not just a straight, subtraction, 40 and then, no. It's there's definitely got to look. So that part going up, it makes the cannonball go up, is going to be V initial Y equals 20 meters per second. There. Oof. Now what am I going to do for my sheet? That was the explanation of why it works. Now, what are you going to put down? Well, V in the X component is going to be the full 40 cosine 30. The Y component is the full 40 sine 30. What are these numbers? Well, we just put that in the calculator. We got, what did we say? The X1 is 34.6 meters per second. And the up one was 20 meters per second. You got to repeat that everywhere.